Have you ever stopped to think about what it really takes to keep the massive infrastructure of the energy industry, well, running? Today, we're going to pull back the curtain on the unseen world of industrial maintenance. We're exploring the absolutely critical and often pretty dangerous job of cleaning the very arteries of the energy sector.
All right, let's just jump right in with a question that gets to the heart of it. Picture a truly massive steel tank, okay? One that's been holding crude oil for years. When it's finally empty, what do you think is left behind? I'll tell you this much, it's not a simple rinse-out job. There are some serious hazards just hiding in there.
You see, these industrial vessels are the lifeblood of the whole operation. But over time, they develop this nasty cocktail of internal problems that you just can't ignore. And this buildup is not just grime. It is a direct threat to safety, to efficiency, and to the environment.
And what's really wild is just the sheer variety of gunk that builds up in there. I mean, we are talking thick, heavy sludge at the bottom, sticky hydrocarbons and wax clinging to the walls, and a constant fight against rust and corrosion. Then you throw in some rock-hard scale and leftover chemical residues, and you've basically got a recipe for disaster. Get this, in some cases, this sludge can eat up over 10% of a tank's capacity before it's even flagged as a problem.
So why is this such a big deal? Well, because this stuff has serious consequences. It can literally choke the flow of product, it can lead to catastrophic failures as corrosion just eats right through the steel, and it can cause unplanned shutdowns that are incredibly expensive. Even something as basic as a sensor reading becomes totally unreliable, which, as you can imagine, could trigger a whole cascade of safety events.
To really get a handle on this challenge, you have to understand the scale we're dealing with. These are not small containers we're talking about. These are industrial giants, and each one has its own unique design, its own purpose, and its own set of problems. And this slide, wow, it really lays out the sheer scope of it all. The cleaning arena covers everything, from those massive crude oil storage tanks you see near a refinery, to super high-pressure vessels, complex separators that have to split oil, gas, and water, and even the receivers at the very end of major pipelines. Each one of these is its own unique, complicated puzzle to solve.
So, how in the world do you clean something so massive and so contaminated, right? You can't just send a guy in there with a bucket and a mop. No way. This kind of monumental job requires a specialized, seriously high-tech toolkit.
The first tool in the box is just pure raw power. High-pressure water jetting or hydrojetting is pretty much exactly what it sounds like. It uses these incredibly focused streams of water to literally blast away the toughest stuff. We're talking hardened scale, corrosion, you name it, all without damaging the vessel itself.
And to put that power into perspective for you, look at this number, 40,000 psi. Your car tire has about 35 psi. This is a mind-boggling amount of force. It's so powerful, it can actually cut through steel. This is not your garden hose, folks. This is an industrial scalpel made of pure water.
But you know, brute force isn't always the answer. Sometimes you need a little finesse. That's where chemical cleaning comes in. It uses these very carefully engineered formulas, think specific acids or solvents, to dissolve the gunk that's chemically bonded to the surface. It's like a targeted strike against specific contaminants that water jetting just can't touch.
And then for the really heavy-duty jobs, you have mechanical cleaning. This is the hands-on, physical removal of all that bulk material. We're talking about bringing in powerful vacuum trucks to suck out sludge and using specialized pumps and scrapers to handle the heavy solid buildup. It's often the very first and most essential step when you're dealing with extreme contamination.
This little table here sums it up perfectly. You've got hydrojetting for extreme power on hard deposits, chemical cleaning for targeted chemistry on specific residues, and mechanical cleaning for just getting the sheer bulk of it out of there. But the real takeaway is that it's rarely just one method. The pros create a custom strategy, often combining all of these tools for a specific job.
But sometimes, all the technology in the world can't do it all, and people actually have to go inside. This is where the human element becomes so incredibly critical. When manual entry is the only choice, it is a massive undertaking. It requires highly certified confined space teams, continuous gas monitoring, and a dedicated rescue team on standby at all times. They're literally the last line of defense in an unbelievably hazardous environment.
Okay, so how does this all come together? How do you turn this toolkit into a successful mission? Well, applying these tools isn't random. It's a highly structured, super methodical process that is designed from the ground up for maximum safety and effectiveness.
The whole operation follows this strict 5-step workflow. Everything starts with a meticulous assessment and a solid plan.
You can't fix a problem if you don't fully understand it. Then you move to isolation and safety, locking everything down to make the area safe to work in. Only then does the actual execution, the cleaning, begin. Afterwards, there's a thorough inspection to verify the job was done right, and finally, waste management, to make sure all those hazardous materials are handled safely and legally.
So, after all that high-tech work, all that careful planning, what's the payoff? Well, a successful industrial deep clean delivers some tangible, really critical benefits that ripple across the entire operation. First and foremost, enhanced safety. By getting rid of flammable gunk and stopping corrosion dead in its tracks, this work eliminates those hidden risks of fires, explosions, and catastrophic failures.
Next up, you get improved efficiency. It's simple. A clean vessel is a productive vessel. It restores the full storage or processing capacity, and it makes sure all those critical instruments and sensors are giving you accurate readings again.
And of course, this all translates directly to cost savings. Proactive cleaning prevents those incredibly expensive unplanned shutdowns, and it significantly extends the functional life of these multi-million-dollar assets.
And finally, it ensures environmental compliance. This entire process is built around managing hazardous waste the right way, which prevents contamination and helps companies avoid massive regulatory fines.
This chart just sums it all up beautifully. Professional cleaning sends safety risks way down, while dramatically pushing operational efficiency and the lifespan of the asset way up. It's a clear transformation from a state of liability to one of total reliability.
When you get right down to it, this hidden work is the backbone of what you could call industrial hygiene. It's a specialized, super demanding field that is absolutely essential for ensuring the reliability and safety of the energy infrastructure that, let's face it, powers all of our worlds.
So we'll end on this thought. We all know the modern world runs on energy. But the next time you flip a switch or maybe fill up your car, maybe you'll think about the unseen professionals out there who are tasked with one crucial job: keeping the engine clean.